Good day, everyone. Our topic for today is all about the measures of central tendency. Now, the measures of central tendency help you find the middle or the average of a data set. In statistics, the three most common measures of central tendency are the mean, median, and the mode. Each of these measures calculate the location of the central point using a different method. Okay. So we have here the mean, which is the most frequent value, the median, the middle number in an ordered data set, and also the mode, the sum of all values divided by the total number of values. Now, in addition to central tendency, the variability and distribution of your data set is important to understand when performing descriptive statistics. Okay, so distributions and central tendency. We have here the normal distribution. So in a normal distribution, data is symmetrically distributed with no skew. The mean, median, and mode are exactly the same in a normal distribution. So we have here an example. Let's say you survey a sample in your local community on the number of books they read in the last year. So, a histogram of your data shows the frequency of responses for each possible number of books. From looking at the chart, you see that there is a normal distribution. The mean, median, and mode are all equal. The central tendency of this dataset is 8. We also have the skewed distributions, where more values fall on one side of the center than the other, and the mean, median, and mode all differ from each other. One side has a more spread out and longer tail with fewer scores at one end than the other. So the direction of this tail tells you the side of the skew. We have an example of a positively skewed distribution. So in this histogram, your distribution is skewed to the right and the central tendency of your dataset is on the lower end of the possible scores. In a positively skewed distribution, mode is lesser than the median and median is lesser than the mean. While on the negatively skewed distribution, mean is lesser than the median and median is lesser than the mean. So in this histogram, your distribution is skewed to the left and the central tendency of your data is set towards the higher end of possible scores. Okay, now let's discuss each of the central tendency. The mean is the a data set is the sum of all values divided by the total number of values. So it's the most commonly used measure of central tendency because all values are used in the calculation. The mean the mean is the arithmetic average and it is probably the measure of central tendency that you are most familiar. Calculating the mean is very simple. You just add up all of the values and divide by the number of observations in your dataset. First, you add up the sum of all values, which is the 287 plus 345 plus 365 plus 298 plus 380, that is equal to 1675 in our sample. And then you calculate the mean using the formula. So there are five values in the data set. So n is equal to 5 while mean is equal to 1675 divided by 5, that is equal to 335. So we have a mean of 335 milliseconds. Outlier effect on the mean. So outliers can significantly increase or decrease the mean when they are included in the calculation. Since all values are used to calculate the mean, it can be affected by extreme outliers. An outlier is a value that differs significantly from the others in a data set. So in the sample shown is we swap out one value with an extreme outlier. So due to the outlier, the mean becomes much higher even though all the other numbers in the dataset stay the same. Now we have a mean of 444 milliseconds based on the sample. Okay. In this histogram, the calculation of the mean incorporates all values in the data. So if you change any value, the mean changes. However, the mean doesn't always locate the center of the data accurately. Observe the histograms as shown in the slide, where we display the mean in the distributions. In a symmetric distribution, the mean locates the center accurately. However, in a skewed distribution, the mean can miss the mark. So in the histogram shown in the slide, it is starting to fall outside the central area. This problem occurs because outliers have a substantial impact on the mean. Extreme values in an extended tail pull the mean away from the center. As the distribution becomes more skewed, the mean is drawn further away from the center. So consequently, it's best to use the mean as a measure of the central tendency when you have a symmetric distribution. Now, when to use the mean? Whenever there is a symmetric distribution or continuous data. Okay. One of the most used statistical functions in Excel is the average. So calculating the average in Excel is much simpler than it was in the school. So simply use the average function and select the range which needs to be averaged. So in the example here, we want to know the average of the marks obtained by the students. So we use the formula in Excel that is equal to average and drag drag and drop until a B2 up to B12, and you can get the answer of we have the average of 61.90909. Okay, next is the median. The median of the median of a data set is the value that's exactly in the middle when it is ordered from low to high. So we have an example. Let's say you measure the reaction times of seven participants on a computer task and recognize them into three groups. We have the slow, medium, or fast. So to find the median, you first order all values from low to high, then you find the value in the middle of the ordered data set. So in this case, the value in the fourth position. The value is in the fourth position. In larger datasets, it's easier to use simple formulas to figure out the position of the middle value in the distribution. You use different methods to find the median of a dataset depending on whether the total number of values is even or odd. Okay, so we have a median of an odd numbered dataset. So for an odd numbered dataset, find the value that lies at the n plus 1 divided by 2 position, where n is the number of values in the dataset. So in the example, you measure the reaction times of in milliseconds of 5 participants and order the dataset. So the middle position is calculated using the formula n plus 1 divided by 2, where n is equal to 5 because we have 5 participants. So that is 5 plus 1 divided by 2, that is equal to 3. So that means the median is the third value in your ordered data set. So that is 345 milliseconds. Now we also have the median of an even numbered data set. So for an even numbered data set, find the two values in the middle of the data set, the values at the n2 and n n divided by 2 plus 1 positions, then find their mean. So you measure the reaction times of 6 participants in order and order the data set. So to get the median, take the mean of the two middle values by adding them together and dividing by 2. So we have here the middle positions are calculated using n divided by 2 and open and close parenthesis and n divided by 2 plus 1, where n is equal to 6. So that is 6 divided by 2 is equal to 3, and open and close parenthesis, 6 divided by 2 plus 1, that is equal to 4. So that means the middle values are the third value, which is 345, and the fourth value, which is 357. So 345 plus 357 divided by 2, that is equal to 351, and that is our median. Okay. So median is a function which is used to find the middle number in a given range of numbers. When you are finding median manually, you need to sort the data in an ascending order, but in Excel. You can simply use the median function and select the range and you will find your median. So we take the same example as shown in the slide to find the median of marks obtained by students. So we use the formula equal sign median and B2 up to B12. So we have a median of 64. Okay, so now let's test the median on the symmetrical and skewed distributions to see how it performs. And we'll include the mean on the histogram so we can make comparisons. In the first paragraph, in a symmetric distribution, the mean and the median both find the center accurately. They are approximately equal. While on the second graph, in a skewed distribution, the outliers in the tail pull the mean away from the center towards the longer tail. So for this example, the mean and median differ by over 9,000, and the median better represents the central tendency for the distribution. Now, when do we use median? We use it whenever there is a skewed distribution on the data, continuous data, or the ordinal data. Next is the mood. The mood is the most frequently occurring value in the dataset. It's possible to have no mood, one mood, or more than one mood. To find the mood, sort your dataset numerically or categorically and select the response that occurs most frequently. So, the mood is the value that occurs most frequently in your dataset. On a bar chart, the mood is the highest bar if the data have multiple values that are tied for occurring the most frequently. You have a multimodal distribution if no value repeats the data do not have a mood. We have an example. So in a survey, let's say you ask 9 participants whether they identify as conservative, moderate, or liberal. So to find the mood, sort your data by category and find which response was chosen most frequently. And to make it easier, you can create a frequency table to count up the values for each category. Now, the mood is easily seen in a bar graph because it is the value with the highest bar. Okay. So when do we use the mood? The mood is most applicable to data from a nominal level of measurement. We have the nominal data is classified into mutually exclusive categories. So the mood tells you the most popular category. For continuous variables or ratio levels of measurement, the mood may not be a helpful measure of central tendency. That's because there are many more possible values than there are in a nominal or ordinal level of measurement. So it's unlikely for a value to repeat in a ratio level of measurement. We have an example. We have an example of ratio data with no mood. So let's say you collect data on ratio on reaction times in a computer task and your data set contains values that are all different from each other. So in this data set, there is no mood because each value occurs only once. Okay. In the graph of service quality, very satisfied is the mood of this distribution because it is the most common value in the data. Notice how it is at the extreme end of the distribution. Okay. Finding the mood for continuous data. When you are working with the raw continuous data, don't be surprised if there is no mood. However, you can find the mood for continuous data by locating the maximum value on a probability distribution plot. If you can identify a probability distribution that fits your data, find the peak value and use it as the mood. An example is the probability distribution plot displays a log normal distribution that has mood of 16,700. Now we use the mood when we need to have a categorical data, ordinal data, count data, and the probability distributions. In the Excel, mood helps you to find out the value that occurs most number of times. When you are working on a large amount of data, this function can be a lot of help to find the most occurring value in Excel. Use the mood function and select the range you want to find the mood of. In our example here, we use the formula equal sign mood and then drag from the particular cell, and since two students have scored 55, we get the answer as 55. Okay, which is best, the mean, median, or the mood? So when you have a symmetrical distribution for continuous data, the mean, median, and mood are equal. In this case, analysts tend to use the mean because it includes all of the data in the calculations. However, if you have a skewed distribution, the mean is the best measure of central tendency. When you have ordinal data, the mean or mood is usually the best choice. For categorical data, you have to use the mood. Next topic, we have the standard deviation. Okay. Standard deviation is a statistic that measures the dispersion of a dataset relative to its mean. So it is calculated as a square root of the variance or the spread of numbers in a dataset. So determining the variation between each data point relative to the mean is valuable for comparing data sets of data that may have the same mean but different range. We have an example. The mean of the following two data sets in the same, but the latter is clearly more spread out. So we have 15, 15, 15, 14, and 16. On dataset 2, we have the 2, 7, 14, 22, and 30. So if the data points are further from the mean, the deviation within the dataset is higher. The more spread out the data, the higher the standard deviation. So standard deviation is often used in finance. It's applied to the annual rate of return of an investment. The higher the standard deviation, the greater the variance between each price and the mean, which reveals a larger price range. Volatile stock has a high standard deviation, but blue chip stock or a large company with a positive reputation has a low standard deviation. Okay, now what is the stdev function in the Excel? Stdev function is categorized under Excel statistical functions. The function will estimate the standard deviation based on a sample. So we have a formula of equal sign stdev, the number of or the particular Excel. So stdev can be useful in using the annual rate of return on an investment to measure its volatility. A risky stock will show a higher standard deviation, while a safer stock, such as blue chip companies like the Apple or Coca Cola, will show a lower standard deviation. Okay, so how to use the stdev function in Excel? First, suppose we are given the test scores of students as shown in the slide. Then second, for the standard deviation, the formula used is the stdev. And then after that, we get the result. Next, we have the variance. Variance is a measurement of the spread between numbers in a data set. The variance measures how far each number in the set is from the mean. So, using using a data set chart, we can observe what the linear relationship of the various data points or numbers is. We do this by drawing a regression line which attempts to minimize the distance of any individual data point from the line itself. In the chart as shown in the slide, the data points are the blue dots, the orange line is the regression line, and the red arrows are the distance from the observed data and the regression line. So when we calculate a variance, we are asking, given the relationship of all these data points, how much distance do we expect on the next data point? This distance is called error term, and it's what variance is measuring. So by itself, variance is not often useful because it does not have a unit, which makes it hard to measure and compare. However, the square root of variance is the standard deviation that is both practical as a measurement. Okay, calculating variance in Excel. We have here a formula of var.s and then we select the data. The reason you want to use var.s and not var.p, which is another formula offered, is that often you don't have the entire population of data to measure. For example, if we had all returns in history of the SPY ETF in our table, we could use the population measurement var.p. But since we are only measuring the last 20 days to illustrate the concept, So we will use var.s. As you can see, the calculated variance value of 0.000018 674 tells us little about the dataset by itself. If we went on to square root that value to get the standard deviation of returns, that would be more useful. So that's it, and thank you.